This is Chapter 10, Temperature, Thermal Equilibrium, and Heat. The unit will run from April 7th to April 16th. Homework is to review the Chapter 10.1 and 10.2, watch the screencast, and if there are any YouTube videos, watch those, take a practice quiz, and you will be tested in the next period. Some quick review. Work is defined as a force times a distance. Energy is the ability to do work. And the law of conservation of energy states that energy cannot be created or destroyed, but it can be altered from one form to another. The learning targets for this chapter section are: I can relate temperature to the kinetic energy of atoms and molecules. I can describe the changes in the temperatures of two objects reaching thermal equilibrium. I can identify and convert between Fahrenheit and Celsius and Kelvin temperature scales, and I can describe the principles of conservation of energy to calculate changes in potential kinetic and internal energy. We first did a demo with pop-in popcorn. Popcorn requires the steam to expand. The oil transfers the energy from the heated oil to the popcorn and heats up the water inside. Temperature is a measure of how cold or how hot something is relative to a standard and is usually measured with a thermometer. At higher temperatures, the molecules move faster and have more kinetic energy. At lower temperatures, molecules slow down and produce less kinetic energy. In the simplest case of the ideal gas, temperature is proportional to the average kinetic energy of molecular translational motion. In solids and liquids, where molecules are more constrained and have potential energy, temperature is more complicated. Temperature is not a measure of total kinetic energy. You have two objects or two sources of water, a swimming pool and a bucket of water. They both have the same kinetic energy per molecule and have the same temperature, but the pool has far more total kinetic energy than the bucket of water. Which has more molecular kinetic energy, a bucket full of warm water or a small cupful of higher temperature water? Depending on how great the variation is between the temperatures, in all likelihood, the bucket of water will have more kinetic energy than the cup of higher temperature water, even though the molecules inside the high temperature water will have more kinetic energy. This is a table that describes different forms of energy: translational, rotational, and vibrational. Thermal energy is the idea that heat flows between objects that are in contact with each other until they reach the same temperature. At this point, the objects are said to be thermal equilibrium. Two objects in thermal equilibrium do not necessarily have the same internal energy, and a thermometer reaches thermal equilibrium with a substance that it is measuring. There are three temperature scales that we use: Fahrenheit, Celsius, and Kelvin. Fahrenheit is 9/5 times Celsius, and then you add 32. Converting from Fahrenheit to Celsius, you add or subtract 32 from the Fahrenheit temperature, and then multiply that entire number by 5/9. And Kelvin is adding Celsius and adding 273 degrees. 0 on the Kelvin scale, which is an absolute zero, corresponds to the lowest possible temperature, and the molecules no longer have any kinetic energy to give up. Absolute zero is only theoretical temperature that corresponds to minus 273 degrees Celsius. Internal energy or thermal energy is a measure of the total energy of a body. This includes translational kinetic energy, rotational kinetic energy, and potential energy. When two bodies of different temperature are in thermal contact with one another, energy will flow from the body with the higher temperature to the body with a lower temperature. This process is called heat or heat flow. Heat transfer is driven simply because there is a temperature difference. When a hot metal sample is placed in a bucket of room temperature water, heat flows from the metal, which has less internal energy, to the water, which has more internal energy. And heat always flows from hot to cold. Thermal units are energy, so you can measure it in SI units, and the SI unit for heat, or thermal units, is a joule. 1 calorie is 4.184 joules. What I'd like you to remember are joules and calories. Law of conservation of energy is that energy cannot be created or destroyed, but it can be transferred or transformed from one form to another, including transformation into or from mass as matter. The equation is delta potential energy plus delta kinetic energy plus delta internal energy must be equal to 0. Here is an example of how to work one of the problems. It is very likely you will see something very similar to this on the quiz tomorrow. Make sure you review Chapter 10.1 and 10.2. Make sure you've watched this screencast, and if there are any YouTube videos online, make sure you take the practice test. You will be taking the quiz next class period.